I will talk about all the steps of the counting circuit project, which include the button input, the NAND gate oscillator, the decade counter, the decimal counting binary up-down counter, the 7-segment display, and the final PCB. The first part of the counting circuit is the button input. It uses a 9-volt power source, a button switch, a red LED, a 10 kilo ohm fixed resistor, a 4011 chip. This circuit is made so the switch is a high. This means when the switch is not pressed, the LED stays on, but when the button is pressed, it turns off. This is because it uses a pull-up resistor configuration, which allows a high output when not connected to ground, and a low output when the button is pressed. The next part of the circuit is the NAND gate oscillator. It adds a few new parts, such as a 47 ohm fixed resistor, two 1 million ohm fixed resistors, a 10 microfarad capacitor, a 0.1 microfarad capacitor, and a PH4148 diode. The purpose of the NAND gate oscillator is to provide a clock signal for the circuits. Clock signals are periodic square waves that oscillate between a low and high state at a constant frequency. There are two resistor pairs in the NAND gate oscillator. One controls how long the oscillation happens for, and the other controls how often it happens. The third part of the project is the decade counter. The different parts it uses are 10 yellow LEDs and a 4017 chip. The 4017 decade counter chip converts the oscillation outputs to a counting signal. The chip uses the oscillation signals from the NAND gate oscillator into pin 14, the clock pin. Then it is divided through the other pins. The next part of the project is the decimal counting binary up-down counter. The different parts it uses are a slide switch, 4 yellow LEDs, and a 4516 chip. The 4516 is a binary up-down counter chip, meaning it can count up and down based on the inputs it receives. This is a BCD counter, which means it can process the binary coded decimal. In binary coded decimal, each digit represents a 4-bit number. For example, if the binary input was 3, the chip would have a 0011, or if the input was 11, the chip would output 1011. The final part on a breadboard is a 7-segment display with a counting circuit prototype. The different parts it uses are 7 680 ohm fixed resistors, a 7-segment display, and a 4511 chip. The 7-segment display is controlled by the 4511 chip. The 4511 uses binary coded decimal inputs and converts them into decimal notation for the display. Each output of the chip is connected to one of the 7 segments on the display with a resistor. The final counting circuit uses a PVC, and all of the parts are soldered into it. The PVC is placed on a 3D printed case with the battery inside. There is tape over the battery so none of the parts short. This final circuit can count from 0 to 9 and back from 9 to 0.